to the same result, we have to use a trig identity. So 1 minus cosine theta, and this is very important for Calc 2, not for today, not for Calc 1, but we need to remember these trig identities. So this is 2 sine squared theta over 2. So that would be our first step if we want to continue like this. But since I have it here, allow me to continue and show you both ways. Okay, so we have limit as theta approaches 0. I will factor out -1. I'm going to copy this as is first. And maybe I should just leave it alone with theta squared because it's not going to work with that method anyway. So I'm not going to separate it because we get 0 over 0 again. Okay, I will factor out -1 in the numerator. 1 minus cosine theta divided by 2 theta squared. I'm going to replace 1 minus cosine theta with this identity, with minus in front. And now, all I need to do is realize that this is sine squared of theta over 2. I have to multiply here by 4 and divide by 4 because now these will give us what we want, because when theta approaches 0, can anyone tell us where will theta over 2 go? If theta approaches 0, where is theta over 2 going?
Zero.
Yes, of course. Thank you very much. I will simplify one of these 2's, and this will approach 1. Let me rewrite it. Sine theta over 2 over theta over 2, everything squared. This piece is sine theta over 2 squared, and theta over 2 squared is theta squared over 4. If this one has power 2, then this one has to have power 2. Otherwise, it's not going to be 1. So this piece approaches 1, and I still have -1 over 4. But this was a little bit longer because we needed to identify the cosine minus 1, which is a super important identity. Basically, 1 minus cosine theta, which is the half angle identity. So 2 sine squared theta over 2 is 1 minus cosine theta. So once I realized that and I replaced this by sine squared, the denominator only needed a 4. Multiply by 4, divide by 4, and this squared basically is theta over 2 squared. And this now, all this, is 1. Because I do have the rectangle, I do have the rectangle with, 2 here and squared, and I do have this. But I have to notice that this is this squared. So we realized that something needed to be done because we obtained another 0 over 0. And then what do I do now? I cannot change this into 0, and I cannot change this into 0 because then, well, how do I continue? So we had to go back and use trig identities. Good. Do you think we had enough from 3.3? Can we move on to the chain rule now?
Yes.
Okay. So, because I have 4 minutes and I have like 15 minutes left from this video that I'm recording right now, we're going to have a discussion to work on in 15 minutes. So please don't go away. Okay, so we are moving on to section 3.4. And this is extremely important method of differentiation. It's called the chain rule. Before we even talk about the chain rule, nobody cares about the chain rule before we discuss this. Let's suppose I have the cube root of 2x to the 4th plus e to the x. We will decompose with our mind, not really on paper. We can, of course. We will, the first one. Decompose this function into, we discussed this some time ago once only, inner and outer. Yes, you can come up with more than one inner and one outer, but I want one, just one. Yes, there is more than one correct answer. But I want just one inner function and one outer function when you look at this. So remember what we said, always try to simplify. Please try to simplify functions first. Where is that second one? Right here. Please try to simplify if you can. So here we're trying to decompose in order to understand what the function is telling us in order to differentiate it later. So what does the function tell us? What is the inner and what is the outer? By inner we mean if I ask you to evaluate this function when x is 0, what would you do first? Which portion or piece of it you will do first? And which piece of it you will do second?
The outer is definitely the cube root.
Correct. So it's just the cube root of x. It's the function itself. Good. And what is the inner?
Everything else?
Yes. 2x to the fourth plus e to the x. So this is the inner. This has to be evaluated first. Evaluate that first. And this, which is the cube root of x, evaluate second. Perfect. So once we know that and we see that, and yes, we, as I said, we may have more. Oh, here's another example, which is way more complicated, of course. So you can see that not only two functions can be involved. So I can have something like cosine of the cube root of tangent of 3x. Wow. Innermost. Next. The innermost function is 3x. The next innermost function is tangent. The next innermost function is the cube root. And the next one is cosine. So here we came up with 2, one outer and one inner. But here I have 4. So in this situation, the general case, if you remember, it's F comp G. F comp G. The composite, or the composite of F and G. Okay? So this by definition is F of G of X. G is the closest to X. This will be the inner, of course. And after we are done with this, so we get a number, then we apply this function. So this is the outer. But now the problem is, how do we differentiate? When we have functions of functions, we will use the chain rule. So, if I have x to the third, and I differentiate, I get 3x squared. But what I should have said, I lied to you a little bit. What I should have said is this, times the inner function prime. This is the outer, this is the inner. 3x squared times x prime times the inner function prime, or if you want differentiated, times the inner function differentiated. That's what I mean by prime. But why didn't we do that? So actually I didn't lie to you. So why didn't we do this?
Because it's always one.
Exactly. But can anyone give us, based on what we just discussed, the definition of a function to a power, not x, but a function to a power prime? Can you mimic this and tell me what to write?
raised to n minus 1.
Times the inner function prime.
X prime or 1?
The inner,
The function prime.
exactly. Exactly. There is no reason to write x prime because we know it's 1. This is no longer x. This is a function of x. It can be natural log x, it can be e to the x, it can be anything. Right? So, let's apply this quickly in a couple of examples, and then we'll look at the other one. So let's suppose we have, and I wanted to discuss this first before we use it in a problem. What about this formula? Can anyone give us this formula? So all these have to be on your notes. Very important. Okay, so mimic this, remembering what the square root of x prime is, and can anyone give us the formula for the square root of f prime?
Is it 1 over
Yes,
square root f?
2.
yes, the square root of f times
F prime.
yes, times the inner function prime. Awesome. Great job. What about this? X cubed plus 2x to the 10th power. Would you sit here and take this to the 10th power? No, no, no. Because we can find an expression for the derivative. What is it? Who would like to help on this one? Yes, I'm ready.
Okay, it's going to be 10 times x cubed plus 2x raised to the 9th power times 3x squared plus 2.
Excellent. That's it. That's the chain rule combined with the power rule. I didn't even tell you that. So it's the chain rule combined with the power rule. So now let's look at the general case. A function of another function prime. Exactly the same, but no powers. So it's f prime of g of x times the inner function prime. Good. So let's open the floor for any discussion, any questions, anything you would like to pick. Please don't tell me I'm logged out.
Can we at least like talk, if not actually solve the one that you had up there that was like 4 functions? And is it essentially you just continually
Yes.
add out? That's why it's called the chain rule.
Yes. So please remember, do not put a plus or a minus in these situations. It's all multiplied. Yes, we can look at that one. So we have cosine, before you choose, that's fine, of the cube root of tangent 3x. Perfect. So, cosine prime.
Negative sign.
Good. Of the whole thing. Right, I know you, yeah, that's another word I asked. That's all I needed from you. Yes. The cube root of tangent 3x. Times. Now I have to differentiate the cube root. Remember, the cube root is something to power 1/3. So we bring down 1/3 times this to power 1/3 minus 1, which is negative 2/3, times tangent prime. What is tangent prime? Derivative of tangent.
Secant squared.
Yes, secant squared of 3x in this case, times the innermost function prime. What is the derivative of 3x?
3.
Yes. Gee whiz, a lot. So let's summarize. So see, when we decompose the function, we basically go from inner outer. This is the first one that I evaluate. and when I'm done and I get 15, then I apply the second function, the outer function, and take the cube root of 15, if this is 15, or whatever I get. But when I differentiate, I go from the outer, step by step, to the innermost. I differentiate the cosine of this argument, so it's minus sine of the cube root of it. Then I have to differentiate the cube root. It's a function to 1/3. 1/3 times the function to negative 2/3 times the inner function prime, which is secant squared of 3x, times the further inner function, the last one, prime, which is 3. Any questions?
Is that solved?
That's it. What we can do here is just simplify this 3 with this 3, and that's it. Just rewrite it one more time if you want, or just leave it alone. It's multiplied, it's multiplied. Careful with the chain rule, because I see a lot of students put a plus here, and plus, and plus, and plus, and minus. No, 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 no. Please be very careful on that. Okay, so we're ready to work on 7 through 52. Some of them are, you know, we cannot work on this one just yet. Don't choose it. In a minute, I'll explain. Many of them are not friendly functions, but it is what it is. We cannot choose 26. Say it again.
10.
10. We want to look at 10. Fine. Good pick. F of x equals 1 over the cube root of x squared minus 1. Perfect. Awesome. Good pick. Excellent. Thank you. Good. So let's analyze and let's look. What do we conclude? What will you do first here?
Identify the inner.
Not yet. We have one more very important step before that.
Simplify.
Yes, how will I manipulate the function to benefit me?
Get rid of the cube root.
How? Excellent. This benefits me, this doesn't.
Negative 1/3.
Awesome! That's it! Who wants to apply the quotient rule or something like this? And have 1 in the numerator, which the prime is 0, and one of the two terms has to go away, and I have to be careful. No, 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 no. Yes. Good. So can anyone give us f prime for this? Now it's just a blink. Here's, oh my goodness, what do I do? This is just a blink now.
Negative 1/3
Awesome.
times parentheses x squared minus 1 to the power of negative 4/3.
Awesome. Times,
2x.
exactly. Done. If you want to rearrange it, yes, I'm going to put negative 2x over 3 in front, and then change this maybe to, you know, the cube root of x squared minus 1 to the 4th power. Okay, but this is it. I don't have to use anything else.